As you said, pretty much every other meta-analysis on this topic has kind of only investigated one or two buckets of studies that were ultimately included in our analysis. For the most part, exercises that expose the muscle that is being measured for hypertrophy and particularly are challenging in that position seem to also be the studies where you don't need to go quite as close to failure.
Welcome to the N1 Experience, brought to you by N1 Education, the leader in fitness education. Hey, what's up, everybody? I am here with Zac Robinson today, one of the authors on the new meta-analysis that I guess it's a meta regression is a better way of putting it on training to failure. And we're going to dig into that and the training to failure research as a whole. So really quick, before we get started, why don't you give us a little bit of information about yourself and the data-driven strength team and kind of what you guys are doing. And then we can kind of roll into this new meta-analysis that everybody's talking about.
Cool. My least favorite part of every podcast here, but quick rundown to myself. My name is Zac Robinson, currently a PhD student at Florida Atlantic University, working on my PhD kind of related to resistance training, all that good stuff. Specifically, my PhD is actually going to be in individual response to resistance training, which I'm sure we can have a good chat about given the name of your company. So that's one of my favorite topics as well. But specifically, I did my master's thesis and obviously this project related to proximity to failure. Our lab at FAU does all kinds of stuff related to program design, things like that. And Data-Driven Strength is just a company of myself and some other individuals that are just trying to take the research and break it down as practically as possible to give people some better advice and places to start when they're training. But as you know, it's only a place to start, and we kind of have to navigate using our in-trenches experience from there. So kind of trying to combine all those spokes of information to make it as practical as possible for people that are just starting to train all the way to advanced lifters. I'm really excited to kind of discuss the project here with you today, Kassem. I think there's obviously some important things that go out in terms of the methodology, but this project in particular I think is really interesting to get a lot of the interpretation through someone like yourself with a ton of in-trenches experience, the lens which you view those results, and ultimately some of the finer nuances in terms of applying it, I think will be interesting. And I think you have some particular expertise in certain questions that I have had kind of reviewing this on the back end that I'd be interested to get your take on. So I'm excited to chat today for sure.
Awesome. So to start, you've covered this study pretty well, I think pretty thoroughly on the Revive Stronger podcast. And we will put that link down below so you guys can kind of, if you guys want to get a kind of more thorough breakdown of the study design and how it was done and just another great conversation, I suggest you guys check that out. So we're going to kind of try and build upon that rather than just repeat it. But if you had to give us the cliff notes of kind of what you guys did and maybe how this is different than the previous meta-analysis that was done, what's like the quick version of that?
Absolutely. And I'll try to keep things pretty brief here. If there's anything else you want me to explain a little bit more, just let me know. So long story short here, this topic in particular, so proximity to failure for resistance training and its application to strength and hypertrophy, has essentially always been investigated in a binary. So failure versus non-failure. There's a few other areas of research that have put it in categorical terms as well. But obviously, when we're going to actually make training prescriptions, understanding the entire nature of the relationship of proximity to failure and its relation to a training outcome, understanding that whole dose response curve can be really, really helpful. And so that was kind of the mission that we sought out to try to achieve. Now, when you go through every one of these individual studies, you quickly realize that unlike how we would, do in a training context where we write down the RIR, at least that we perceive on every single set, some individuals may even reference some sort of velocity profile to objectively try to assign RIRs. We're really dealing with sparse data there in terms of the actual published research. So what we had to do was go through every single one of these individual studies in as systematic but inherently subjective way as possible to estimate RIR in every single one of these studies so that we can perform an analysis that actually allows us to quantify the dose-response relationship between proximity to failure and these training outcomes. As far as what we found, it seems that for strength, I guess I'll say that one first, strength seems to be essentially a negligible relationship with proximity to failure when you meet a few specific conditions. And the main one there is at a given percentage of 1RM. We can go into that a little bit more if you want to. I think you're more interested in the hypertrophy kind of conversation if I'm accurate in that. So we'll keep rolling on that. In terms of the hypertrophy relationship, the the statement that I would come away from the paper with is that there seems to be a relationship between proximity to failure and training outcomes for hypertrophy. That seems that as you get closer to failure, training outcomes seem to improve. That's probably where I would stop with confident statements due to tons of things that go into the actual analysis and how the actual dose response curve ends up looking. And so that's basically where I would stop, is to say there's a meaningful relationship between proximity to failure and hypertrophy, such that as we get closer to failure, training outcomes improve. But there's tons of additional context in terms of the volumes, the sets or repetition equated studies, all kinds of different things that we can get into. But as far as the cliff notes and the main points that we can take away from there, that's where I'd say. And then the additional one component I would say is that seems to be further mediated by the load used, such that heavy loads for hypertrophy, somewhere greater than about an 8 RM or so, I would say, proximity to failure seems to become substantially less important. So from my perspective, I think this kind of relates to the anecdote that people seem to have with multi-joint exercises. So for example, when you think squats, generally speaking, people tend to feel that you don't need to take those as close to failure as comparison to a leg extension. From my perspective, although this is one of the questions I have for you, some other factors related to those exercises, I think that's probably because people just habitually tend to train multi-joint exercises with heavier loads, such that the proximity to failure doesn't seem to matter quite as much. That would be my kind of elevator pitch on kind of what we found. But of course, there's tons of limitations and additional kind of nuances that are important to consider when practically applying that.
So when it comes down to trying to put as much data together as you guys did, so I look at this topic as when you're trying to investigate training to failure, like you're in a sea of confounders.
Absolutely.
Actually, right?
Yep.
So the pro, or what you're trying to accomplish, is trying to basically get enough data to hopefully overpower that mass of confounders, right? And so that's because some people ask, well, like, why don't we just rely on the single study that's doing the direct comparison to get this? And, I mean, we could spend a whole, like, probably several episodes just getting into all of the confounders, but, a lot, like, just to throw out a couple examples, like one would be like, depending on what the current volume tolerance is of an individual in a study, right? Well, if one group's training closer to failure and one group's training further away, if you're at somebody's volume limit versus if it's kind of a very under volume, you might get, drastically different responses in those people, right? And then there's going to be differences between different exercises with different resistance challenges. There's just all of these variables. So I think, in general, the whole purpose of a meta-analysis is to take a topic where it's got a ton of that. And then the more data points that we can get, the more confidence we can get that the signal we're seeing is actually, causation to the thing we're trying to investigate, and trying to eliminate the signal of the confounders. Now, I know one of the critiques is maybe we don't have enough studies on this topic, but I think that's kind of what your goal was by kind of expanding what was eligible to be part of this conversation, because, the meta-analysis, the one that came out a little bit earlier in 2023, that was more of a looking at just the direct studies, right? And so what are the things that got added in to your meta-analysis that were excluded from that prior one?
Absolutely. Yeah, that's an absolutely perfect way to kind of paint the narrative. So as you said, pretty much every other meta-analysis on this topic has kind of only investigated one or two buckets of studies that were ultimately included in our analysis. So obviously you have the studies, like you said, that are very directly designed to answer the question of failure versus non-failure. That's kind of the most standard bucket of studies, and those are the ones that have been predominantly focused on in all of the previous meta-analyses. I can't recall exactly how many studies the recent one had, but I think it's somewhere around 10 to 15-ish, if I recall correctly, somewhere in that range. So that's one bucket of studies. Another bucket of studies are those that directly report RAR, and that might be like subjective perception thereof, so some limitations associated with that, but at least it's some sort of data directly quantifying proximity to failure in some way. So I think a lot of the time those are also included in those papers as well, depending on the study. Now, as you very correctly point out, we kind of expanded our inclusion criteria to encompass, from my perspective, all of the data that is relevant to this question. Importantly, there are important caveats associated with that, which we kind of teased out with some of the moderator analyses that we can go into if you want to. But put simply, there was kind of two other buckets that, based on the estimation process, we could kind of bring into the equation to give us more studies and, as you said, more observations that will hopefully allow us to tease out this relationship accounting for all this other noise that is in the system with the study designs. So those two areas are the velocity loss research. So just to very simply kind of summarize what one of those studies would look like, you have two different groups. Both of them are training with 3 sets at, let's say, 75% of their 1RM. So number of sets is equated, load is equated, and repetitions are rest is equated, let's say. One group will train to a 40% velocity loss threshold, which means they're going to continue doing repetitions within each set until the bar speed declines by 40%, versus another group that does the exact same thing but only goes to a 20% velocity loss threshold. So those are indirectly manipulating proximity to failure by terminating the sets at different percentages of the velocity decay within a set, which is going to be related to how close to failure you are. Now, the limitation with those studies is that they're also manipulating a secondary metric of volume. I guess in hypertrophy, we normally focus on the number of sets, but the kind of hidden premises in that usually are that it's generally above 5 reps or so to count it, and generally that it's close enough to failure. So it ends up kind of being tautological in the regard to the proximity to failure comment, because that's what we're trying to investigate. So because the number of repetitions are changing, that's could be substantially different volumes at the end of the study. I think sometimes the higher velocity loss groups are doing over 100% more total repetitions. So that's something that's important to take into account, which we did in the analysis. But those studies were able to be included because we were able to take those velocity loss thresholds and equate those the best we could to an actual RIR. Now, there's a bunch of limitations with that, but that was one of the reasons we were able to include those. The second group of studies, that's probably the one that people are less familiar with in terms of the hypertrophy research, are what are called alternative set structures. And so basically those use 2 different types of rest redistribution, basically, to terminate sets farther from failure. So once again, let's take the example of one group does 3 sets of 10 with a 10 RM. So 3 sets to failure, basically, with 10 reps. These other groups, these alternative set structures, are going to intersperse rest periods between those same 30 total repetitions to make the cumulative amount of work done farther from failure. And so again, those are kind of brought into the equation because we're able to, through a variety of different methods, estimate the RER in which those groups are training as well, and then we can kind of bring those into the mix. Obviously, as you said, for those, there's also the confounder of the differences in rest periods, which need to be accounted for, and at least see if those seem to make a difference. But we're taking them into this whole conversation because they do manipulate proximity to failure. They do measure hypertrophy and can conceivably give us information on those outcomes in terms of that relationship. So those are the 2 main areas that kind of got brought into the equation. I think people would be a little bit less familiar with in terms of like one cohesive analysis. The velocity loss stuff has been analyzed separately, but together in concert with all this other data hasn't really been analyzed together because we haven't had a way to actually quantify RIR to give us a consistent metric across studies to actually combine. So that those are the 2 areas I would say that are important to kind of outline.
So one of the set types of that latter group would have been cluster sets, right?
Correct. Yep.
And that's actually one that I was curious if you could kind of walk me through how you guys were estimating the RIR on the cluster sets.
Yep, absolutely. So there's a number of assumptions that needed to be made with the alternative set structures that at face value are tough to just kind of ignore, but there are kind of counteracting issues that we kind of ultimately decided on, that we were just going to go with what made the most sense and was the simplest. So to give you an actual practical example, in a cluster set study, what you might have is one group that does, like I said, kind of 3 sets of 10 RM. So that's pretty straightforward. Hopefully they provide some sort of failure definition that we can kind of confidently say that that group is 0 RIR. For the cluster set groups, specifically, the difference there is that they're going to have those little interset rest periods, but they're also going to have a greater intraset rest period. Sorry, I flipped those. Interset rest period. So every group's resting 3 minutes. The cluster set group gets that, but they also get to intersperse their repetitions with little mini rest periods. So basically what we had to do for the cluster set research, we looked through a lot of the acute data on cluster sets. And so basically you take one group that does 3 sets to failure with a given load, and then another group that takes the same load and uses a cluster set configuration, and you see how many repetitions they can perform. For the most part, a lot of the cluster set data is kind of remarkable in how much performance that you're able to maintain at a given load. So what we did is we basically took the mini set that the cluster set group performed. So in this case, let's say with a 10 RM, they performed, let's say, 2 reps. And we're saying that those 2 reps at a 10 RM load is 8 RIR. and then we're basically able to maintain that for the entire session, basically. So obviously, when you hear that, there's a number of things that come into your mind. Obviously, for the most part, we're going to have set-to-set fatigue that's going to decline that RIR target over time. The rate of that is going to be dependent on the exercise, the repetition range, the initial proximity to failure, the sex of the individual, even the exercise selection. There's a lot of things that are going to go into the rate of that set-to-set fatigue. On the other side of things, we also have strength gain. So a lot of the way that progressive overload is kind of targeted in these studies isn't super systematic, like a double progression or something that happens set to set or even session to session. So as you get stronger, a given load is going to become more submaximal. So you kind of have these counteracting forces that could bias the RIR estimation in kind of either direction. But ultimately, we're taking those mini sets, doing the best we can with the load approximation to rate the RIR of that set, and then making the assumption it's relatively homogeneous across all of the repetitions. That's basically the way those were estimated.
So the cluster set RIR was based on the conditions of, we'll say, the first part of the cluster.
Correct.
Right.
Yep.
Okay. Because I think that to me, that would be the one where most people would have questions. It's the one where I had most questions too. Because like if I'm performing a cluster, the first cluster, if we're using your example where it would be 8 reps in reserve, and then say I rest 20 seconds or whatever it is before I go again, that weight is no longer an 8 RIR of the second cluster, like it's a lower, and then it's a lower or whatever. And so I was just kind of curious kind of how you guys manage that. But if you're basing it off the first one, I mean, I can't even, this sounds like an overwhelming task that you guys were, that you're trying to do, right? So I don't want to be too critical, but that makes me
no.
Maybe the clusters would have been, we'll say undervalued in terms of their proximity to failure if we were gauging them on the beginning. But it's also very hard to measure how many RIR, what's your RIR at the second one, what's it on at the third one, because of all of those confounders. So you had to choose something, right?
But you're totally right, and I think this is the thing I've been trying to, in every longer form conversation like this that's considerably more informative on how to interpret this stuff, is that this stuff is messy. Like there is no way am I out here holding to the fact that these are perfect estimations and this is the model for hypertrophy. Like I do not believe that in the slightest. The way that I think the estimation can inform us on with the best available data that we have, the overall directionality of the relationship that I'm relatively confident in, given just looking at the RIR estimations and like reading the studies as a practitioner, I think at face value, for the most part, they're in the ballpark. But, the way that this relationship can dip and dive, depending on a variety of different things that go into constructing the model, I'm not beholden to any one single pattern related to this. And you're bringing up tons of good points that I'm not just holding a blind eye to. I completely acknowledge that all of those are relevant and all of those can bias the estimations. The hope from our end was that the way that we estimated the studies, we at least try to be wrong in a similar way for all the studies, such that the bias in the overall placement of the relationship could be slightly off. But if we're off in the same direction, hopefully most of the time, that it can at least kind of still inform the trajectory and the directionality. That's not a perfect by any means, obviously, but that was kind of our thinking of using kind of minimal criteria to utilize to estimate the studies, instead of using every single study possible to try to use the same similar estimation procedures to try to make the estimations as consistent as possible. But nonetheless, there are countless factors that we could go into to describe the issues that are associated with the estimation. So we're just trying our best given the data that we have. And the important thing with this is, it's the first step. The ideal analysis here is in 10 years or so, when we have actual good reporting that this analysis is supposed to encourage, that we can do this again and hopefully get considerably more confident in the overall dose-response relationship. But no, I completely acknowledge those limitations, and they're absolutely crucial to employing this practically. And I think that's something that just needs to continuously be stated. So I think those are important to mention for sure.
10 years, dude. Everybody wants the absolute answer now. Like
I've noticed.
Hey, on this podcast, we are going to make the declaration, right? So I just thought that would be an interesting example to go through, because I think most people are familiar with cluster sets, but also that was probably one of the more complex scenarios that you guys had to deal with as well, right?
And I think one thing important to clarify, I've noticed this. I come generally more from kind of like a strength background. So when I hear cluster sets, that means one thing in my mind, like more so in like the power kind of training world, Whereas I've noticed that some people kind of equate cluster and rest pause together in my mind. And so we separated those. So cluster is specifically designed to try to make a given workload farther from failure, whereas there was one study in the analysis that was a rest pause where you're basically trying to make it closer to failure. So just making that distinction clear if that is can be confusing sometimes, I guess. But no, I agree. That's an important case to bring up for sure.
Yeah, that's a topic that we often actually end up discussing is like where does something stop becoming a cluster and become a rest pause and whatever.
Yep.
And my usually say it's like, well, what is your goal? So are you trying to increase the absolute loading over a given number of reps, and what degree of failure you're trying to get to and whatever. It's like, as long as you're covering those things, like don't worry about the semantics, just build it to the outcome that you want. And I think that's why, when it comes to these terms, you have to take it very loosely. And also, hey, this is just throwing this out there because this is a hot topic this week. Like, hey, if somebody says something that is semantically slightly different than yours, maybe don't assume that it's a direct attack on the way that you're doing things, because they may be using like similar language, but actually discussing a totally different thing. And you guys might hate each other, but actually agree on the very point that you hate each other over. Hong Kong, wink, wink. Okay, cool. So I think the next thing I'd like to get into then is kind of what we can take away from the different aspects of this. So if you had to say like, well, what is the most valuable thing that we're taking away from yours versus maybe what's the most valuable message that we're taking away with the previous? And I'm also curious if there's any studies in particular that stand out really well in design that you think are worth noting, because I'm not as familiar with the research, like, I read things and whatnot, but I haven't read every single study fresh again, sure, prior to this podcast. But my overwhelming feeling on all of them is just like, man, all of these have a lot of, like, there's definitely some done more than others, but I don't think we have a perfect, like, bulletproof study where it's like, hey, we have this one that's at least done really, really well, where like maybe we could look at this as like the best, most direct evidence. I kind of look at it as like, yeah, we have a bunch of them that kind of have, we'll say, shortcomings in different ways, but nothing that gets me really excited. But I'm curious, if you think anything stands out.
100%. I think that's really a good way to kind of think about it. So I guess I'll start on the initial kind of comparison to our analysis to maybe previous analyses. So I've seen quite a bit of chatter in terms of like thinking that they suggest completely different kind of conclusions. I personally don't think that's the case. If you go through all of the more typical kind of forest plot, standardized mean difference, meta-analyses on failure versus non-failure, if you go back through all of them kind of in the last however many years, essentially every single standardized mean difference leans in favor of the condition training closer to failure. Now, what happens, depending on how statistics are done, the results are communicated, if we're going by kind of the null hypothesis significance testing kind of paradigm, where a standardized mean difference isn't significantly greater than the other side, then those kind of nominal differences tend to get washed out. And I'm not saying whether that's a good or bad approach, it's just a different lens to view things. If you're, doing all the appropriate things that go into testing hypotheses such as that, it can be a totally fine approach. I think people just often kind of stop there and don't consider that for very, very small differences between conditions, it's going to take a significant amount of statistical power to be able to confidently detect that. So when we're looking at, a 0.15 standardized mean difference between failure and non-failure, which is like a pretty small effect in terms of statistical terms, that's going to take a lot of studies to be able to confidently detect that. And ones that are going to be pretty clear in either direction, have a small amount of variance, et cetera, which just isn't the case in exercise science essentially ever. So that's I guess something that I would go back through and kind of look at all those meta-analyses again and realize that although not significantly greater in most of them, the nominal differences are generally in favor of failure, which when we go to paint this out in this more kind of continuous dose-response relationship, basically agrees. So I think that's an important thing to keep in mind. Now, this is something we discussed on the Revive Stronger podcast that I think is important to mention again, is that ultimately whether that difference is justifiable for you to actually complete an intervention is entirely based on your subjective kind of smallest effective interest And that's going to be characterized by a ton of different things that ultimately determine whether A or B is correct. Just looking at a point estimate and seeing that it's greater than something else does not automatically justify that that is necessary for you to do. So I think that's just important to keep in mind. In terms of weighing this type of analysis or meta-analysis in general versus some studies that we view are very, very strongly able to test the question that we're interested in, I think that's a really interesting topic. So I guess there's like a study we could use, for example, that I think does a really good job at like kind of isolating maybe the practical question people are kind of interested in. There's a study by Santianello and colleagues that basically is a within participant design, which for hypertrophy is a really solid design because you're controlling for genetic factors, different training kind of leading into the study, et cetera, et cetera. It's just a really solid design. One limb trained to failure, the other limb trained approximately 2 reps shy of failure. And then they looked at the differences between limbs. And I think the nominal differences were in favor of the non-failure limb. And I believe it might have been non-significant in terms of the differences. I can't recall off the top of my head. So someone may see that study and say, oh, okay, this is in contradiction to the meta-analysis. I would have a few points that kind of highlight why looking at individual studies can be potentially misleading. I'm not saying necessarily misleading, but potentially, in that we have a few other things that kind of coexist in this comparison that really can only be identified when we kind of aggregate studies together. So for example, in the Santianello paper, if I recall correctly, they trained the leg extension at 75% of 1RM and the leg press at 80% of 1RM. From our analysis, we know once you're starting to get up in that loading range, RAR becomes less and less meaningful. And so that's an important thing to highlight, that you really can't analyze the effect of those other variables. When you're reading that study, you're just saying, okay, the load's equated, rest periods are equated, volume is equated, we're good to go. But in reality, all of those independent variables are also going to operate on the actual comparison of interest. And so when you actually aggregate all these studies together, then we're able to see if these other factors end up integrating or actually interacting with the RAR relationship, which in the case of load, they seem to. So a lot of these within participant studies that tend to find no differences, that's kind of the direction that I'm leaning in terms of those loads are pretty heavy. And a lot of them use maximal concentric intended velocity, which I also think is an important factor that could potentially influence your ability to train farther from failure and see similar outcomes. So really the only way you're going to detect the influence of those variables is through meta-analysis, which is where kind of relying on single studies can be challenging. Now, to be clear, I'm not saying that that's not a viable position even, and you could take issue with a number of the limitations of our analysis, the RR estimation, some of the subjectivities in terms of the model fitting procedures, all those kind of things. And if you want to, favor that evidence for those reasons, I don't think that's a completely untenable position at all. I would just probably say that I have a bit less confidence taking that approach, even if at face value it seems to be a little bit more direct. The other thing specifically for hypertrophy research that I think people have a harder time kind of conceptualizing, often because it's not reported, is when we read a study for strength, and again, this is kind of where I come from for the most part, you have an intuitive sense of kind of the smallest worthwhile change related to testing somebody's 1RM, testing somebody's 10RM. You've probably done that with hundreds of people that you kind of intuitively know what's if somebody improves their bench press in comparison between two conditions by 2.5 kilos, are you really going to look at that as a difference between conditions? Even if that effect size was, moderate or something that we would generally consider meaningful, you're going to look at that as a practitioner and say, it's kind of a wash. For hypertrophy, that becomes very, very challenging. We aren't familiar with units that are related to hypertrophic measurements, whether that's MRI, ultrasound, whatever the instrument that you end up using. Identifying that smallest worthwhile change from a practitioner's perspective gets really challenging. And I think when you kind of layer that on top of non-significant findings, or even effect sizes that lean in favor of different groups, what you would consider a win for either condition changes substantially. And so then when you layer that on top of the length of the training intervention, trained individuals, what's the topic and the minutia that we're really comparing, I think you end up getting less and less results that you would consider a meaningful difference, to which from my perspective, those kind of real systematic differences across studies might only be able to be identified with just a ton of different studies where we can kind of systematically tease out some of these variables. So for a variety of reasons, I think leaning on individual studies can be potentially misleading, but not necessarily misleading. Obviously, I could be wrong about, favoring those versus the meta-analytic approach, especially given all the limitations that we have. But those are a few of the things that I would consider that could be potentially at play when we're kind of weighing one versus the other. And so generally speaking, I would say a well-done meta-analysis that, has, reported everything correctly, the statistics are done appropriately, which isn't always a given, right? But let's say all those things are kind of checked off. I would say generally I would favor that so long as the question is able to be answered by that approach. But I think, again, a reasonable person could say, in this case, given all of the limitations associated with our approach, I'm going to value these specific studies that I think are more applicable to the context I'm looking to apply them. So hopefully that wasn't too long-winded, but that's kind of the thinking I would have on that question.
Yeah, because I think right now we're kind of probably at a crossroads between having, enough having the quality of the studies to where they need to be, to take a lot from an individual study, and then also like we don't quite have enough data to make like a really confident meta. And the lower quality or the lower confidence, I should say, is probably a better way to put that, of the studies that you have in the meta, the more of them that you would need to then be confident, right? So that, I feel like we're kind of in this ambiguous place right now where we're really waiting for, maybe another, like at least like another 50% of like some really well done things to come put in there. And hopefully then that can kind of like, give us that's probably the point where people probably will say, start taking a little bit more confident conclusion from this. So the next thing that I wanted to look at in terms of the comparison component before we, go into all the nuances is the current, your meta and the previous one, seem to be fairly similar in like the middle of your graph, right? Like that's like, and it's the two ends is where the difference is. So basically like getting to that very, very like all the way to failure, whether we're talking, so like the difference between volitional and momentary muscular failure, like that you guys have this kind of non-linear increase as we're getting all the way to failure, whereas the other one has to dip down. And then on the other side, further away from failure, you guys actually tend to have like a more linear, tail as you're getting further away. And I think that was one of the criticisms that Menno had in his video, was that, the numbers looking very far out from failure seem to be like, oh, it doesn't, we wouldn't intuit that, doing 20 reps, or having 20 reps in reserve that would be that effective. And, I would kind of agree with that.
Yeah.
So I'm curious if you've kind of looked at what it was a category of the studies that you were looking at, or were there any particular ones that really kind of changed those two ends? So why don't we just start with the, all the way to failure. And was there like, have you looked to see like, hey, what's the data here that's really separating our signal from what the other meta had?
Yeah, so I think there's a few things that kind of go into this. So in terms of the actual nonlinearity of the relationship, the number one thing that I'd say is that we're literally looking at, I think it's over double the number of studies. So the kind of the pool of studies that go into assembling this relationship is essentially entirely different. The second thing is, this is the first time RIR has ever been quantified. And I would say after I've done all the estimations, a lot of the studies that people assign to different RIR values in their head, when you actually systematically go through the training program and actually rate the RIR of every single set and every single exercise and every single component of the training program, including the tapers that are actually constituting to the actual RIR average, it's different than what you would expect and in quite a few different cases. Like for example, the Rupel study that recently just came out, I think the RIR estimations included in the meta for that study are substantially different than I think what gets tossed around on social media in terms of the RIRs that are associated with those groups, because a lot of the accessory training that was performed for the muscle groups that were measured for the ultrasound was performed with 3 RIR. And then the actual RIRs for the actual exercises that were manipulated in the protocols had a tapering week that was extremely far from failure. So like that's just an example where those RIR estimates and kind of how those neatly play out in their relationship are slightly different than I think what people intuit and ultimately can inform the relationship. In terms of the specific differences in terms of the last meta-analysis and this one in terms of the comparison of the failure point. I think it's the biggest difference here is just the criteria of what was what we kind of use as our distinction between failure definitions and what the last meta-analysis did, in addition to the completely different pool of studies. The last meta-analysis was, I would consider, much more of a sniper approach. They had very specific conditions for what was momentary muscular failure, what was set failure, what was non-failure, and those were very, very specifically applied to the studies that they had. Ours was a little bit more broad in that we had involuntary versus voluntary set termination. And so when you look at involuntary set termination, we basically accepted any specifically defined failure definition that they clearly explained what they were considering failure, and it wasn't volitional. So it was concentric failure, momentary failure. There's other language in there that I can't totally remember off the top of my head, but anything that was clearly explaining what they were considering the failure definition and it wasn't volitional, that was considered involuntary set termination. Whereas anything else was considered voluntary set termination and was considered zero RAR. So that is kind of a little bit of a different criteria, which kind of puts studies in different buckets depending on how you kind of consider those. The other thing in terms of the actual curve and comparing the curves from the different studies, while I think it's a really solid way that they did it, it fundamentally just isn't the same type of analysis. So they're basically taking the different categorical effect sizes and qualitatively putting those on a curve in terms of their distance towards failure. But the actual position in which those lie, none of those studies were rated in terms of their RAR estimation. So we can't actually assign those in terms of a continuous relationship. So I think assigning those or comparing those two curves just really doesn't make sense to me for that reason. And that's kind of the whole reason that we did this. I think within the context of that paper, I think that's an awesome way of kind of painting the nonlinear relationship that was kind of theorized based on the different categories that they had. But for example, the velocity loss estimations, those alone are kind of very different depending on the load used, the exercise selection, and kind of all those things that we directly rated in this analysis. So I think, again, comparing those two curves, I don't view as a super valid comparison for a lot of reasons. Not to say that one is better than the other, just they're two different approaches. And then in terms of the back half of the relationship, in terms of greater than 10 RIR or so, that's a totally valid critique. And I think the number one kind of reason it looks that way is because there's very few studies that exist all the way out past that relationship. And so that's why in the paper, we directly in the text and not just tucked away in the supplementary file, did a secondary analysis where we only analyzed the papers that had an RIR estimation of 10 or less. And so that basically, I would say, is more of a standard way of people that would think about it. The curve is considerably less aggressive. It looks very similar, and the overall best fit model is very similar, but I would say it's a little bit more realistic. I also would be pretty surprised that 20 RIR is going to give you very similar outcomes to 12 RIR or whatever. But that's just a limitation of meta regression in general when you don't have a consistent amount of data throughout the entire data set. So which is why we preemptively did that sensitivity analysis to make sure we had the estimations in there without that extremely long tail that is based on very, very few data points. So that would be kind of my answer to that, is that absolutely it's a fair criticism, but that's why we try to preemptively kind of tuck that in the paper as well to make sure that those estimations were still holding when we took out that very long tail of studies. I think I hit on everything there, but let me know if I missed anything.
Yeah. So in practice, we find it, and I think we have actually some good evidence now on this, is that it's easier to estimate RAR as we're closer to failure, and then it's harder as you're further away. Do you think that there's probably a little bit of that there too, and that the studies that were just done at a higher RAR, the predictions were a little bit more challenging, or if you had to place a confidence in it, your estimations are probably closer on, we'll say like less than 5 versus over 5?
I see what you're saying. That's an interesting kind of way of thinking about it. I guess I hadn't thought about it that way. So to be clear, I think what you're specifically referring to relates to when we're using perceived RARs. So like when you would rate your RAR and I'm taking that as the RAR estimation for the study, I think there's 2 studies which we did that. Every one of the other studies was basically taking the configuration of the training and using other published research where people basically do reps to failure in kind of variety of different contexts, exercise selection, the sex, the load, etc. And using those relationships based on what they actually did and then estimating RAR through that. So for most of the studies, the perceived RAR is kind of avoided in that regard, and we're basing it on kind of to the best available evidence for those given context in terms of repetitions performed in those instances. So we're kind of taking a guess at the capacity in those conditions, referencing what they actually did, and then popping out the RR estimation. So usually the confidence in terms of those would be essentially the same for if we're using all of those criteria in the same context. The one I would say that I would have the most confidence in is that the studies that said they trained to failure, I'm going to be the most confident in those because we don't have to really do any estimation at that point, right? Because the other ones we would have to use other means. But if they say, here's how we define failure, they took every single set to this point, boom, that's a 0 RR estimation, and I'm the most confident in those. That'd be kind of the absolute peak of the confidence, and then we would have pretty much all the studies else are kind of at this level. I guess you could put subjective RR maybe one level higher than all the other studies, but that would be kind of the hierarchy there, if that makes sense.
I just didn't know if one of the factors that you were using was looking at studies where they're using, a % RM, loading or whatever, is that we end up usually having the same thing. Is the variation in reps is also greater as we're working with lighter loads, which would also be those there. So I'm just curious if if the tools that you're using to estimate this are also becoming less accurate as we're getting into those higher, because we would be at the lower percentage of. So I'm just looking at that as there's a compounding thing going on there.
No, that's an excellent point. Yes, I'm sorry, I didn't quite intuit what you're saying at first, but that's a great point. So basically what you would be saying there is the ability to reach task failure in the conditions that we're using to reference the capacity for a given percentage of 1RM, let's say, are going to be less accurate as we get lower, which will also be the lower RR conditions. I think that's totally reasonable. And that's why another reason probably the uncertainty intervals of the relationship just get way wider the further that you go from failure. So I think all of that is theoretically conceptualized within the actual statistical model, but is that always something that people take away? Probably not. So I think all those are really good points that I think are important to kind of think about for sure.
No, dude, most people just look at the picture, right?
Pretty colors, right?
And a few more of them will listen to this, but then we'll still read the full study, right? So,
right.
Okay, cool. I think that's probably pretty good place of kind of summing up, the difference between the studies. Like I said, guys, he did a very good job of kind of breaking down a lot of these individual points on the Revive. And you guys got into some of the practicality and stuff on there as well, in terms of like looking at, the different rep ranges and how, like, if you're working in a higher rep range, it does seem to be a signal that we're working closer to failure. But I think what would probably be more interested us to talk about is the nuances that probably aren't covered in this, in terms of like different exercises, and like styles of exercises. And, we've posted stuff on, the failure point when something has a short bias resistance profile versus a lengthened. And there's a lot of talk about the, stimulus to fatigue ratio. And I think that is going to be a very exercise dependent thing when we're talking about training to failure. Because when I'm teaching training to failure in our courses, I try to get people to understand, like, physiologically, like what we probably look at mechanistically in these different conditions with different exercises, and then basically getting to that task or momentary failure in those things and how that would differ, so that they can look at the context of an exercise and be like, okay, if I take this exercise to failure within a given rep range and based off of the proximity of that exercise, where does that put me on the physiological spectrum? Because that's ultimately kind of what I'm building my program around. Like, especially I'm focusing on hypertrophy, right? And I'm literally just trying to take all of these things in and just make us like, how do I get a certain volume of mechanical tension, above a certain threshold? And then that's my best proxy probably for hypertrophy stimulus, right? Cool. So you had a couple things that you wanted to say. So if you want to start, go ahead.
It's funny because literally everything you said kind of ties exactly into what I was going to ask you. So one thing that when I was going through this, and this is kind of a thought I've had a while, but I didn't really, consuming some of your stuff, I've been better able to conceptualize how to ask this question. I guess initially there was like something I thought might be going on, but I didn't know exactly how to state it. So I guess I can do a little bit better so now. And I guess my question for you is, I really enjoy kind of some of the stuff you've posted on the different failure points that you kind of mentioned. So something when I've gone through this research purely subjectively, I was initially going to put this in the meta-analysis, but then I realized I was basically just entirely subjectively determining what kind of machine they use. It was similar to something I've done, except basically it's just me deciding what it is on every single study subjectively, which I didn't think was going to be a great way to do it. But for the most part, exercises that expose the muscle that is being measured for hypertrophy and particularly are challenging in that position seem to be the studies where you don't need to go quite as close to failure. So one thing I've thought about is that, we typically conceptualize RIR as momentary failure all the way to, infinity RIR, right? And you've done a really good job kind of showing how this point is much fuzzier than people kind of realize. It's not homogeneous, it's exercise dependent, resistance profile dependent, etc. So I guess, do you feel that it's kind of, if we can expand this side of the spectrum to be like there is an absolute physiological, the muscle cannot produce force anymore, and that occurs in XYZ conditions, and then the shortened end of the spectrum is closer to like just momentary failure where you're just arbitrarily defining the task in a certain way and you're failing there? And do you think that getting to this point is like the truest stimulus of actually being closer to failure? So that's going to be related to exercises that expose you to longer muscle lengths and exercises that are more challenging at those longer muscle lengths. And then it kind of goes backwards from there to being exposing at a shorter length and hardest at a shorter length. Then you kind of get to the more submaximal RIRs. I guess that's something I've just kind of qualitatively looked at this and seems to be the case. The issue with that, in my opinion, again, is kind of from the research line of things at least, is that you have that interaction with load. And so, if you're loading up a squat or you're loading up anything that I think kind of people tend to bias in lower rep ranges, there's that interplay of that. But I know you have the cool machines where you can kind of change that resistance profile within an exercise that you would kind of load in a certain range. So I'm just kind of curious your kind of thoughts on that general concept of like, can we expand the proximity to failure spectrum to still keep it kind of a linear thing, but have this muscle length and the position in which we're defining failure within the range of motion kind of tacked on to the kind of momentary or task failure end of that spectrum? I'm just curious what you think on that.
Yeah, so from a physiological perspective, the perfect failure point would be if you could define at a given range of motion, like how much force production the muscle still had, right? So if you wanted to say like, okay, 10% out of lengthen, position, once we've reached, we'll say 40% of the starting for like of a fresh, right? Like, okay, like that would be our reasonable, like we could set like what would be practical, right? Like, cause you could literally be like, okay, well, we're just going to take everybody in an exercise that's designed to this to failure at a 12 rep range or whatever, and then see see how much actual force loss there is at that specific thing. Then you could potentially create like something that would be like, okay, this is kind of the ideal conditions that we're looking at, and you maybe try and model like what exercises would kind of fit into that bucket. That's probably the best thing that you could do, right? Because theoretically, we're just, when I'm looking at failure, it's just like, well, okay, how much force production has this muscle loss, range of motion specific, right? So if we're comparing exercises that are challenging in the short position, like I've put up a video of us using like the prime arm curl, where you can keep the motion exactly the same, like you said, and just change the resistance, but like have the same, like it always gets challenging when you're just like, well, all right, it's the weight is the same. So at some point in time, like the peak torque point is the same, but the weight over the range of motion is different. So it gets kind of like, cause it's like, do you take exactly like the same force curve, right, and just move it so that the area under the curve is the same? Which is a challenge because you can't just like, oh, I'm just going to take a plate and move it on the machine. You got to know a little bit more of the physics of the machine, but we try and get as close to the same like area under the curve, if you will, when we're kind of making these comparisons. Sure. And the thing you'll notice is that if task failure is the completion of a full rep of an exercise, if we're loading in that short position, that comes way earlier, right? But then the difference is that once you've reached that full range failure with that load, you could then do another rep that might be like 80-90% of the range of motion. And then you might be able to do another rep and another. You can do all these powerful range of motions, right? So the short position failure, like the full ROM, might come earlier, but you have a ton of force production in that muscle still at the other ranges of motion. Now, if we flip that to exercises where the challenge is very lengthen biased, what we kind of have is like you get to task failure, and then you kind of get like a little struggle partial and you're pinned, right? Like this is what happens at the bottom of a bench press or a squat or whatnot. And even some of those exercises, because of the strength curve of the body, even though the resistance is pretty much, very biased to the lengthened, mechanically we're kind of compensating for that. So it's like some of them are not as lengthened biased as they could be. So like, somebody might be able to get like halfway up on a last rep of a dumbbell press or a barbell press or whatnot. But if you get to all the way to the extreme range, pretty much when you fail, that's you're stuck there, right? Which does take some kind of ecological validity away from like using those exercises, unless you have, an environment where you can do that safely, right? And I think that's a huge thing to consider. And and we're not even talking about the difference between multiple joints or whatnot. It's just that, like, okay, if we're saying that, momentary muscular failure is when you can no longer complete this, the physiological conditions there in a muscle or in an exercise that's challenging the short versus lengthen are going to be very different, in a sense that if we're doing the shorten, we probably are significantly further away from failure in terms of physiological conditions at those longer muscle lengths, which if we're kind of seeing that that's where, the hypertrophy stimulus is a little bit greater, then potentially, those are the exercises where we have to go all the way to failure, or maybe even beyond that, right? To get equal benefit in those. So that could be, that's a huge, we'll say, confounder in the data if like one study is using exercises that so anything that's using like a bicep curl or something where there's no load at the bottom, right? Or if they're using cable pull downs, or pretty much any back exercise that's free weight, right, is going to throw that type of signal in the data. And then on the other hand, your free weight chest exercises and leg exercises are going to go the other way. So I don't know if you could kind of look at what you have and see if it's kind of a mixed bag, which would kind of or if there's a disproportionate amount of lengthen versus shorten stuff in there. That would be kind of interesting to know kind of what that distribution was along the studies, because that could give you an idea of kind of where your estimates are relative to the physiological conditions, right? I don't know if that completely answers.
No, yeah, it's an interesting topic, because I think this is I've just thought about it in terms of kind of the interplay with like some of the long muscle length stuff that you guys talked about, and I've talked to Milo about this a little bit as well, and just kind of just the interplay of those two things has always kind of made me interested of is proximity to failure a variable that's basically proximity to failure and exercise selection are both kind of trying to get us to let's get really, really high tension for the muscle when it's at a very long length and high forces at that position. Are those both kind of indirectly getting to the same thing? And when we kind of look at those on an integrated relationship, does that kind of give us even more context for that kind of spectrum? It's just been something I've thought about. And then I guess the other thing we were kind of talking about a little bit before we got started is just, I guess from your perspective, understanding kind of all those mechanics things and whatnot is, I think I've heard you talk about the kind of distinction, and we talk about this a little bit in the paper in the strength portion, in terms of the difference between force on the whole muscle level versus the force on the fiber level. Is that kind of when you read our paper, just kind of when you think about this in general, is that still kind of the lens in which you view proximity to failure and how that is kind of influencing hypertrophy? Or is that something that's changed depending on a variety of factors and whatnot? I guess I'm just curious on how you view that as somebody who I think tends to think pretty mechanistically about this stuff, kind of how you view that relationship.
Yeah, well, the goal is always to try and understand the mechanisms behind the longitudinal results as best you can, because if you're in the field, you have to be able to make, N of one decisions. And the more we understand the mechanisms, the better we can make an N of 1 decision.
Sure.
Unfortunately, sometimes it takes a long time for us to get that. But the nice thing is with an N of 1, you literally you're doing the scientific process at that level. So as long as you're tracking and collecting data, you're at least able to make decisions for that one person. You just can't really take and apply that anecdote to other people. But in terms of the whole muscle versus the individual, we'll say sarcomere level tension that we're going for, that is the mechanism that I think is at the root of why we would benefit from training closer to failure. It's pretty much the main driver behind the force velocity curve, and I think it's also one of the main mechanisms for the benefits of training at longer muscle lengths, right? So if we break those up into pieces, so if I'm a lot of people strength and force and power, we have these different definitions and whatnot, right? And so if we take the force velocity approach, right? So you can be producing a given amount of force, right? But it won't the amount of resistance and whatnot is going to determine the velocity of which that, you end up moving in. So if as you're fatiguing, you have fewer sarcomeres that are able to contribute to that load, you will still be able to move the same mass through space, but it'll just be at a slower velocity. So if we're thinking of mechanical tension, it's I'm looking at that through the lens of okay, we're now distributing the same amount of whole muscle tension, but across a smaller number of sarcomeres, which means that they're likely on average under more tension per sarcomere. So that's the mechanical tension that seems to matter. That's where the mechanoreceptors are or whatever. And so that seems okay, it would make sense that those would be then the conditions that would give us the larger hypertrophy stimulus, is when we're getting to the point where we're able to still complete a task, but we're doing it under the conditions where it's more tension at the actual contractile unit level where those sensors are. And then the same thing for long muscle lengths. So as we're getting into the longer muscle lengths where we're able to utilize some of the passive, the passive portions of Titan a little bit more. So a lot of people use active and passive. My preferred way that I kind of try and explain this is motor and non-motor tension within. So we have the cross bridge, which is motor driven. Sure. But Titan has both active and passive properties, and then there's also the extracellular matrix and all this other stuff coming in. But essentially, if you think of it this way, let's say you have 10 sarcomeres, okay, and they're all basically holding a load, okay. The passive properties of that are going to be stretched relative to the load, regardless if the cross bridges are fully shortened or fully lengthened, right? So what we're seeing right now in terms of the force thresholds of stuff is that pretty much the passive tissues are not going to limit the cross bridge. It would make sense that the cross bridge is able to overpower the passive tissues and not the other way around. Evolutionarily, that seems to make sense. And I'm just going to be honest, some of these Titan studies are a nightmare to try and read and understand, and what they're pushing my mathematical knowledge to the limit. I'll put it that way. So if I get anything wrong here, I apologize. This is not a finalized model. I don't think anybody has one, but the way that I kind of simplify how I see this going on is that, okay, as we're getting to the lengthen position, we're able to use more of those passive properties, especially during the eccentric, right? Part of the reason we see EMG go down in the eccentric is likely because we're actually getting to the point where instead of there being a certain amount of fibers holding the same amount of tension, we're having, again, fewer fibers relative to the whole muscle force, right? And so what we end up having is we have, we'll say these fibers are using their full motor tension, but now because those passive structures are stretched, that's more actual force at the sarcomere level. And so if you combined the effect of training closer to failure and also training at the longer muscle length, you're kind of using two mechanisms to try and get to that, situation where there would be a higher relative force per sarcomere within the muscle, right? And so mechanistically, that's kind of how I look at that. And so you could make the argument that if you were doing exercises that were very lengthen biased, that you could get better or equal benefits from a hypertrophy perspective further away from failure than an exercise that was in the short position, but you were training like all the way to failure, right? Because maybe you're getting the same amount of volume of like whole muscle work or whatnot, but in one situation, you're just not getting to the same per fiber level tension. So the magnitude of that stimulus would not be as much, right?
Yeah. I mean, that's essentially like just purely conceptually. I've tend to think a similar thing. Researcher hat off, coach hat on. Like that's basically what I've kind of thought too, just like subjectively looking at the data, thinking about it a little bit. The one confounder from the data is, like I said, the loading ranges that are used for the length and bias exercises. But now it's making me think that we got to get one of those prime machines and try to tease this out a little bit with, that'd be a cool study to do with basically just changing the resistance profile and then defining task failure in a specific way, and then also having both conditions also go to like physiological failure as you're kind of talking about it and kind of see what happens there. That'd be interesting. I think that's an interesting kind of interplay between those two factors that I think kind of gives even more nuance to the relationship, right? And kind of further caution when interpreting something that, as we've discussed in a paper that we wrote, and there's tons of other review papers that kind of talk about how difficult it is to define failure. And I think you're adding an even additional kind of component to it with the exercise selection and their resistance profile stuff that makes it even more challenging, aside from even just describing what the conditions in which you're taking to failure even more. So I think that's just another layer of caution when interpreting the overall relationship that you got to keep in mind. I guess another thing I have just from your perspective is one thing that this project over the last couple of years has made me probably become more agnostic about is just the fatigue related aspects of things. I think it kind of depends where you kind of come up in the iron game, kind of how that narrative has been pitched in your mind, I guess, is like, you have a camp where, failure is kind of the default approach and like anything else is like you're not training. And then you have the other approach where you take, all the fatigue research, et cetera, like failure is substantially more fatiguing, et cetera. I tend to come back to the fact that like initially I was very much in the camp of like leaning on the acute research of saying, if you go to failure, it's substantially more fatiguing, et cetera, et cetera. I think I've become more tempered in that as I've realized that the epistemic standard that we utilize for that evidence is quite literally not even remotely close to what we use for anything else. So if we only had a body of acute evidence to make a claim, we would never have anything that's confident. I think in this case, it's because it so strongly aligns with our subjective anecdote that it's something we just kind of take and run with. But to my knowledge, there's literally only one published longitudinal study, and then also my thesis data that have looked at the longitudinal aspects of fatigue in relations to different proximity to failure. And for mine, there really wasn't a difference between conditions. And then the other one, they did seem to adapt over time. So to me, when you kind of evaluate this relationship, if you take things at face value and say that there is an incremental difference between whatever the way that relationship looks, but there seems to be an incremental difference between, failure and 2, 3, 4 RIR, it goes from there's essentially no benefit here, to which we analyze the cost benefit, to there's a potential benefit here. So now the cost benefit analysis changes a little bit. And I guess I've just sat on the cost end of things and kind of tried to really think about that a little bit more. And I guess I'm just curious with your experience, like, do you think the fatigue associated with training to failure, and obviously, as we just mentioned, that's not a homogeneous term, but I'm using it that way for now. The fatigue associated with that, the psychological approach to what a 0 RR prescription says on the paper and kind of how you execute that. How do you think all those things kind of play out over the long term? Is that a concern we should have? Is that something that you think we can pretty strongly adapt to and isn't as big of a limiter as some people would like to think it is? I guess to the closing thought here before I finally let you talk and not just keep rambling. I think there's a pretty big difference between performance decrement in the acute sense and then actually not being able to benefit from additional stimulus. I think those two things, I think people often think are the same thing, and I do not think they are. Like if you train to failure, you may lose more reps at a given load, but I don't think that necessitates that you're able to benefit less from a stimulus, if that makes sense. So I think those are just a lot of thoughts I have on fatigue, and I'm just kind of curious to get your take on a lot of that stuff, the data, your experience, etc.
So I think it's tough to put failure and fatigue as things that are always going to have a direct relationship, because there's going to be so much variation between exercises and the amount of volume doing and et cetera like that. So if we go through the exercise lens first, right? So when we have what I would say are biased exercises, where basically there's a muscle or a division of a muscle that has a very biased, advantage in the exercise. So your failure point is going to be extremely related to the fatigue in that specific muscle, right? That's very different in exercises where maybe now we're compound, or the motion isn't very specific to that tissue. So at one part of the range of motion, you're leveraging one tissue, and another part of the range, you're leveraging different tissue, et cetera. In those conditions, now the limiter is not as well defined, and the ability to compensate is bigger. And sometimes that is visually apparent, and sometimes it's not. So I believe listening to on the Revive thing, you guys kind of talked about, machines versus free weights. And I would kind of push back on that a little bit and be like, there is an aspect to that, but it's not, it's still, to me, is more going to come down to the mechanics and what can be leveraged. Because let's say you're doing a chest press versus a dumbbell press, right? Mm-hmm. Well, in a dumbbell press, you have to balance it, meaning you're actually going to be limited in how much you can deviate the force production amongst the muscles, because you have to maintain that certain discipline. But in a chest press, well, your triceps don't care about balancing a fixed handle. So they can, they can start to become more a part of the lift. Same thing with your deltoids and pecs and different divisions of those. Like, so you basically, because you're kind of pushing into a fixed object, you can use friction and all sorts of stuff in other directions as you're approaching fatigue. So you may have started with like, hey, my pecs are doing the majority of this work, but as I'm getting closer and closer to failure, the amount that I'm able to compensate with these synergistic muscles is going up and up and up. So the fatigue now that you're going to get from that is going to be very different, because basically now you're coordinating a whole bunch of other tissues. You're basically taking something that started off as a more isolated exercise, and it's becoming more of a systemic exercise across basically every joint involved in that environment, which is one of the reasons why, you can do something like a leg press and like get to the point where you're extremely systemic fatigued, right? And with a squat, especially if you're doing, we'll say, not a ridiculous rep range, you can definitely get to fatigue, but maybe not quite to the same fatigue that you could with a leg press, because with the leg press, well, when your quads are giving, your glutes can help a little bit more, your adductors or whatnot. Where in a squat, you may actually see the point at which, okay, quads are done, now my butt's kicking back. I could qualify that as like, all right, this is technical failure, or I could still go. But like, you can only leverage the glutes so much, because at a certain point, your technique can't deviate still past the point at which you would no longer be able to balance it, right? So you have more opportunity to compensate in a squat, because you can move the hips and the knees back and forth, than you can in a dumbbell press. Because as soon as the dumbbell, if you're using, a decent load, as soon as that starts deviating in terms of rotation or elbow flexion or whatever, all of a sudden now you're actually going to really be challenging the exercise, in a different way, and likely, you're going to reach that failure point just via another mechanism. So I think it's going to come down to a lot of like, hey, for these exercises, how specific is the motion? How many joints are involved? And what is the limiter to my ability to compensate in this, right? And free weights, a lot of the times, it's literally just going to be balance, on a lot of those things. And with machines, it's going to be like, hey, how many different ways can I push in this fixed path, right? And still do that. So with the more biased an exercise, basically the greater the percentage of load that's being moved by the prime mover relative to the synergist. So that means that there's going to be less of a gap between once you reach a certain fatigue and that, prime mover to where like the synergist could help. But in less specific muscle or less specific movements, those synergists can get involved to a greater degree and kind of actually like we'll actually even see on surface EMG that as you're approaching failure, you'll actually see the activation in the prime mover drop off.
Yep.
Now you won't, like if we're comparing say like a bicep curl, you won't see that. You'll see the activation peak at the very last set. And if you keep doing partials, it'll still be the thing because you have limited options there. Same thing if we're doing a very specific type of cable like fly or press that's like very aligned with a division. And you can't really use, triceps to bully a cable press, or biceps to bully a cable fly type of thing. We'll see that basically that activation stays biased towards that. But in movements that are less specific or movements where you can compensate and produce force in different directions, we'll actually tend to see that switch. So if we're thinking of like, okay, what's that failure point? Would we qualify that like some of these exercises are going beyond failure for that particular, like you're able to go past failure, meaning that you're able to go to the point where this that muscle group has now reached a point where instead of it getting like more and more relative tension, it's now on the descending curve in terms of how much it's contributing. And that's probably where you would see the separation of, okay, this extra fatigue is no longer coming with an accompanying benefit for that tissue. But let's say you are in the, you train more, RP Mike Israetel style where your exercise selection is designed to try and hit a whole bunch of tissue. You could take that same rationale and be like, well, actually, this works in favor because instead of doing exercises for all these different muscles, what I'm going to do is I'm going to pick an exercise and I'm going to hope that the synergistic impact is enough stimulus for all of that other stuff so that I can get a lot out of a few movements. And I think there's a valid rationale for that, but you're kind of, doing the Jesus take the wheel approach in terms of who's going to work, how much. Like, so, if your goal is just, hey, work things hard, get bigger, cool. But if you're trying to be a little bit more informed in terms of where that stimulus is going, then I think that's a bad approach. So like, if you're getting to the point where you're trying to be specific with your physique goals, then I think that that's a very poor approach. But if you're like, you're just starting out and you're just saying, hey, I'm limited in time or number of exercises, or, I'm new and I'm trying to learn, get effort out of the fewest movements possible. You could make the argument that taking that approach there might be like the fastest way, or we'll say like the most efficient way, like to get results per set, right? But as you become more advanced, I think those tables flip, and that now you're going to need to have a more specific stimulus to continue to drive significant results. And also you're probably reaching to the point where you, like, even if you're not in a physique, sport, you'll notice that people tend to they just naturally have strong and weak body parts or whatnot. And, for a variety of reasons, you may want to balance that out, right? Whether that be from, an orthopedic health, perspective, or a physique perspective, or simply the fact that like, hey, if you develop all of your strength in a certain number of tasks, that may have very poor carryover to certain other tasks. And you might want to have a more balanced, strength, across different movement patterns, et cetera, whatever. So then having that specificity, I think, really pays off. So what I'm trying to get at without rambling on too long is that, my approach is the best one. That's first off what you should take. But no, actually, because we teach both things. It's just that like the algorithm basically filters out that the more specific exercises we do are the ones that more people will see or whatnot, because like everybody's posted a dumbbell press and a dumbbell row at this point, right? So, but if I post a special cable pull down or whatever, then everybody gets, all excited. I think both are valid, but I think it's very important that you understand the difference in how you're applying those, and also understand that, there's going to be if you're doing a very biased exercise, you're going to get a very biased fatigue response. It's going to be very specific to that, and it's not going to be as global or systemic, right? If you're doing the other approach, you're going to get a larger fatigue response across more things. But the benefit in that situation is you got stimulus in other areas, right? But it may have potentially limited your stimulus in the primary area, right? Whereas in the other one, you get more stimulus in the primary area, but you maybe didn't get as much of a radiant effect of stimulus, right? And so both approaches are valid. I personally, like if I'm writing a program, I like to have as much control over the outcome as is possible. And so I'm going to use that approach more often, regardless, even if it's a general population or whatnot, because then it's like if I'm looking outside the lens of like, hey, just this exercise. I'm looking at, well, how is that fatigue, spreading across the whole workout if I have multiple exercises? And then how do I use progressions and change mesos and whatnot? And if you have a better understanding of what you're stimulating and whatnot, then it's very easy then to make, the next decisions. If you're just like, hey, do this exercise, see what happens, cool. Now try back exercise B and let's see what happens there. I mean, by all means, you could take that approach, but my coaching philosophy is like, I like to make more informed decisions, than that. Yeah.
Sure. Okay. Two follow-ups / clarifications for me, just to make sure I'm spitting back what you just said. So coming back to kind of the machines versus free weights thing, I guess what I took back from you is those things are just kind of tags we can put on exercises, but the actual principle that we care about is the degree of compensation that occurs relative to the muscle group we're trying to train. And that's not only going to affect the stimulus, but also the fatigue that is associated with it. Is that kind of accurate? Okay, cool. So that's interesting. I guess I hadn't thought about that in terms of like the lateral forces or things like that you're potentially going to be able to produce in terms of like a machine that, and maybe I oversimplified on the other podcast, but that's an interesting way to think about it. And I think that makes sense. I guess coming back to the fatigue aspect of it. So let's say, you kind of painted those two different conditions in an exercise where there can have a meaningful degree of compensation to which the fatigue tax is kind of spread over greater regions, and that's going to be a little bit more systemic, versus an exercise where very little compensation can occur, maybe is a little bit more local, and I would assume a lesser absolute fatigue task. That makes perfect sense to me. I guess what I'm interested in your experience is at a fixed one of those. So let's say, same exercise, same degree of failure, same loads, all those kind of things within an individual over time. Is that something that becomes less of an issue in terms of your mind, in terms of thinking about, okay, just to put a number on it, I guess, is like this leg press to this degree of failure with this load, this rep range, this RIR, this number of sets. Does that 10 units of fatigue change over time such that it gets greater, lesser, whatever kind of trends you've seen, so that you can program around that? Or is that something that you think is kind of relatively consistent as it gets stronger, loads go up, auto-regulation occurs, whatever? Is that something that you find adapts over time and is still something we need to be very, very, not to say that we don't need to be concerned about it, but I guess the calculus changes a little bit there. Is that something you think adapts?
So I think the repeated bout effect applies to both, but I would say I think the stimulus to fatigue ratio favors the more biased specific exercises, especially as you get bigger and stronger.
Sure.
I think then, this is interesting. I mean, right now, there's always spats going around in the fitness industry or whatnot. And, some of the things, that I'll see is just like, there's like, oh, these little guys don't train hard or whatever. And the big guys that are on all the extra, vitamin S or whatnot, or, train a different way. And one of the things that I think, the scientific community could benefit from is actually getting to work with more of that population, being like having trained athletes that are like, they're normal humans like you and I, right? Yeah. And then working with other people that, man, they got 2 arms and they got 2 legs, but like, that's about all that we have in common at this point, right? Like the phrase I like to say is that, all lions are cats, but not all cats are lions, right? And a lot of things change when you got guys that, they're over a 25 FFMI, right? They're just huge, right? And, there's so many things that come into like just the capillarization and the ability to get blood flow and that, right? And then all of a sudden, the tissue forces and like there's just so many things that change once you reach, like kind of a, pun intended critical mass, if you will. And what I've seen anecdotally in that population too is that you've seen a tremendous amount, and this is both like even like natural bodybuilders, like Alberto Nunez is a good example, right? I mean, very good bodybuilder, but by no means like by open bodybuilding a mass monster, right? Like, he's not walking around, at 260, 280 or whatever, right? With 22-inch arms. They look like they're 22 in the right lighting, but
Sure.
but it's just these guys that they got more miles of training on them too. But as they get bigger and whatnot, these exercises that are less specific just seem to have a higher fatigue cost, and potentially there is a ceiling on the specific stimulus that, as you're getting more and well trained, is becoming like, we'll say, less efficient or less stale. Like the stimulus cap on those, and the greater fatigue that you're getting from simply like, hey, the more muscle mass you have, now if this exercise is also synergistic, that is a greater systemic load, both not just on the nervous system, but on the cardiovascular system, from a blood flow perspective, all of that, right? Like if your whole back is bigger, using your whole back is a greater systemic demand versus, if you're, a beginning bodybuilder or whatnot, normal size or whatever, it's like, okay, cool. Maybe it's easier for your lungs and your heart and your kidneys and all that stuff to easily support you doing an exercise that uses half your body. But, if you're, big Rami, maybe doing calf raises is the same systemic, taxation, right? Because, I mean, you don't proportion. I mean, some people, unfortunately, do get some negative, we'll say like internal organ, hypertrophy and stuff like that. But like the rest of your body does not adapt proportionately to when you start adding super physiological muscle onto your frame. And I think that's a big difference between, the very genetic elite and the enhanced relative to most other people is like, it's just a different world when we're talking about like, hey, this person is now doing this with loads and tissue that is kind of beyond what we're kind of biologically evolved to, at this point or whatnot. Like, so a lot, I would say like some of the rules start to change. And I think that's where the argument of like, oh, hey, this isn't really reflected in the research. Like, okay, we use trained subjects or whatever that could squat double body weight. And I'm like, okay, that's cool. Right. But I've also watched guys squat, that same population. I've also watched guys do like 25 reps with those persons 1 RM PR, right? With short rest intervals or whatnot. And it's just like, okay, this is a totally different thing. I mean, one of the like interesting things sometimes is like when you work with that population, like the amount of fluid shift that can happen within a set, and then the amount that can happen like, over the course of a session and stuff like that. Like it would even just simply like keeping that tissue hydrated when you have that much, or seeing the amount that blood flow can shift. Like, when you have that much muscle mass, it's pretty, like it's different doing like an upper lower body superset when you're big and strong versus when you're a general population person. Like one of the things that we'll cover in our courses is like, look, actually some of the most insane workouts on paper are actually great for general population because they're just limited on how much output that they can put in, right? They don't have the neurological efficiency. So even though they reach failure, they're not able to recruit as many motor units and whatnot. So failure for them is not failure what it is for a more trained individual and a big one. But I'm like, look, you shouldn't look at these like super complex, or very difficult rep schemas and things like that as necessarily like these are for advanced people. It should be like, you should look at for what they give, because if you could give these programs to people that are relatively new, and they might enjoy the hell out of them, right? And it might be a good way to overcome the fact that they just can't get as much out of a single set. And then if you give that same program to somebody that's huge and advanced, you may murder them, right? Like that. It's just, it's very interesting that once you reach a certain level of strength and mass, like it's almost that it flips and like, okay, actually now a lot of what I'm doing as a coach is trying to find ways to limit fatigue. And at least anecdotally, a big part of that has been using more of these biased exercises, right? So that we can be more precise with the stimulus and limit the fatigue. Because the systemic fatigue that you can get when you're just that big and that strong, and it's just disproportionately high, at least in my experience.
Interesting. Okay. So it sounds like to me, obviously from a program perspective, it's been clear throughout this conversation how many different levers we can pull, right? So it sounds like to me, from your perspective, let's take an individual intermediate stage, and as we kind of transverse them as they get more advanced, obviously fatigue management is an important part to program design. That's not what I'm trying to disregard, but it sounds like to me what you would prefer in most cases, probably subject dependent, is instead of pulling the proximity to failure lever in terms of manipulating that wildly different for super well-trained individuals, we're going to go to other means for fatigue management, whether that be exercise selection predominantly is the thing you mentioned. I'm sure volume is part of that equation for you as well to some capacity. Is that accurate, or is that, I guess maybe if you were working with an individual that already is a very biased program to start, as they get more advanced, are we still going to move that proximity to failure kind of lever to manage fatigue at all, or is that something you generally are going to keep pretty consistent for the principles of hypertrophy essentially at all times?
I'm still going to pull that lever, but I think where you decide to pull that lever becomes more important, right? So in a beginner, you have more options of where you can pull that lever, right? Like, sure, you can make people do a tremendous number of very hard things, right? And as somebody gets stronger and more advanced, not only does the stimulus need to be more specific, so in terms of achieving your goal, but from a fatigue management perspective, there's also, I would say, fewer options on the table that have a good like cost to benefit ratio to pull that lever. So if you still want to incorporate, squats just for the sake of squats or whatnot, yeah, that might not be the place where I pull that lever, right? It's especially like, it's kind of weird because for something like a squat, I'd say it's almost kind of like, it's not necessarily the best thing for a beginner to work that hard because, there's a coordination demand or whatnot. But for the intermediate, it might be a great place. But then again, once you become advanced, then it kind of, then the fatigue component. So the skill component is the limiter for the beginner, and the fatigue component is the limiter for the advanced person. But for the intermediate person, that might be actually like, that's kind of the sweet spot where, cool, you can do squats and you can train them, close or, to, volitional or technical failure. But once you reach a certain kind of loading and whatnot, you're probably going to start to see that stimulus to fatigue ratio starts to become disproportionately worse than exercises like a hack squat or a pendulum that offer a little bit more stability and a little more isolated limiter to the quadriceps.
Sure. Okay. Yeah, no, that makes sense to me. It's kind of similar to how I think about it. Is basically in concept, it is more fatiguing. We probably want to keep our training there for the most times in terms of like an overarching principle. There's probably like a sweet spot that we want to try to maximize the stimulus within. And then on the individual level, whether that's because they're super strong, they have a very high degree of compensation for a given exercise as to the way they complete the task, or whatever the reason may be, once the individual has presented you evidence that this is an inefficient exercise for whatever the goal may be, and maybe reaching that is one of the criteria for that, is then probably pull some levers, make some adjustments. And I think a heavy squat is a good example there. Like, especially if you're lifting heavy loads, that from our analysis doesn't seem to be necessary to maximize the stimulus in the first place. But even if you're lifting a moderate load, that may not be the exercise that is going to allow you to maximize the training stress within that kind of window across the entire session, mesocycle, et cetera. So yeah, I agree with that. It's just interesting to hear your kind of the way you think about it. So that's cool.
So the other thing I think that's worth laying on that, let me know if we're getting short on time here.
No, we're good.
Is then not just which exercises, but where within the workout that you choose to pull that lever, I think is another important thing to consider. Sure. Some people like to take the approach of, all right, they're going to look at it as like, okay, my first set is where I'm the freshest and I'm going to be able to perform the best. And they'll take that set to failure and then have like sets of diminishing performance afterwards. That's not the model I like. I actually like to have like the last set of an exercise be the one to that. I think especially if we're talking about strength, that's for sure. Like, I don't think there's any argument that if you were going to include failure training and your goal was also strength, that's the way that you would go, because your average loading would be much higher versus just having like one exposure maybe at a higher loading. But I think if we're looking at volume of stimulus, in every proxy way that I've kind of been able to look at, the variables, it seems that placing that failure towards the end, you're able to get a higher volume of stimulus. Whether I'm trying to calculate like effective reps, or relative volume load, et cetera, all of those seem to come out in favor of kind of like having, your last set be the highest effort set. And I don't know if you agree with that or whatnot, but I think especially in real world practice, that seems to play out better. But also I would say, per our previous topic, in the exercises where there is more opportunity for compensation and stuff, this becomes even more apparent. Mm-hmm. And then if you're using like non-traditional set methods, then also like say you're doing supersets, for example, right? Or pre-exhaust and post-exhaust and all those methods, knowing where to pull the lever, not just, on the last set, but like, hey, if you're supersetting 2 exercises or you're doing a pre-exhaust or post-exhaust, knowing like, okay, just because it's a pre-exhaust or post-exhaust doesn't mean the first thing has to always be all the way to failure, right? Or the second thing or whatnot. I think understanding kind of how to pull those levers or whatnot is useful. Mike Guzzutil and I think our first debate was actually on, it wasn't supposed to be on this. It was supposed to be a biomechanics talk. And then we ended up talking like an hour of the difference between pre and post exhausting, leg extension versus squat. And a big part of my argument is like that if you did the leg extension first, right, you're going to want to compensate in the squat. And the squat offers a tremendous degree of compensation. And we know that if we pre-exhaust something and then go into a compound, that we tend to see less activation and, from that. So like, it's like, okay, if we're looking at 2 of those type of exercises, like, maybe it makes sense to put the squat first. And then it's like, well, if your goal is, you're doing this just for the quads, you don't have to take the squat all the way to failure because you have the leg extension. So that could be like the perfect way of saying, hey, I'm going to train this leg extension and I'm going to be very disciplined on the technical failure point from that, right? I'm not going to try and push the lever here. I'm going to make sure that like on this, my squats are absolutely perfect and they're doing what I want, because then I can go to the leg extension and not have to worry about that compensation and know that now I'm going to get a great return on the effort and pushing that lever closer to failure there. And I'm still going to get that cumulative benefit of doing the squat motor pattern. It's just that I'm going to be able to get better physiological stimulus in the quad specifically without now adding in the, systemic fatigue and the lumbar and the glutes and the compensation and all that stuff.
Yeah, no, that makes perfect sense to me as well. I view it very similar. Like, I guess to me, the thing from like a theoretical perspective that I'm trying to do in my head is like I was saying, there's the optimization problem that you're trying to solve for the individual that's going to maximize the stimulus within this window that we've predefined as kind of the most efficient window for training stress. The piece of it that you're layering onto it that makes that even more specific is that that's not just like a general concept, like that is tissue specific, so that when we layer that onto it even more, the example that you're kind of giving is in my experience accurate in terms of like, if I was to go balls to the wall on a leg extension before a squat, that's basically going to become a good morning after that in terms of the where you're going to want to compensate that load. And so that training stress that's optimized within that window may be better accomplished by performing the squat slightly submaximally to not distribute that load elsewhere, and then go into the leg extension, and then in a more, pre-constrained parameters, being able to push that all the way to the point of failure that you want with very little compensation. So I think that makes perfect sense to me, and that's how I think about it, even from the, okay, how should we program RAR within an exercise to kind of optimize that kind of concept. I think, I think it's just, it's dependent on the exercise, dependent on the loading range, et cetera. Because, for example, like if you're bench pressing, for example, and you're doing sets of, 5, or even just lower repetitions. I think the proximity to failure you can get away with minimal performance declines set to set is very different than if you're doing sets of 30. So that's another layer onto that conversation. I feel like in addition to just the degree of compensation that you can get within a given exercise. So I think that matters as well. But I would tend to favor kind of the last set. Seems to make sense to me as well, where you're going to be able to maximize the training, the high quality, high performance training within that kind of RAR window. That's would be, at least right now, the kind of the position that I take. And then for strength, I agree. The kind of from at least from our analysis, the hypertrophy and strength relationships are very different. And I think that's because in one end, kind of with the mechanism stuff, at least the way that I currently think about it, researcher hat off, coach hat on, and is the kind of the when one case we're trying to maximize that per 5 retention, and the other case we're trying to maximize the whole muscle force. And from strength, whatever is going to allow us to do that, which is basically lift the heaviest load possible with minimal intraset fatigue, that's what's kind of going to help us do that. But for hypertrophy, it's going to be the exact opposite. So yeah, that's basically how I tend to think about it as well. And it's interesting to hear just I think me and a lot of people have been elucidated to some of the nuances of exercise selection that you've kind of really brought up, and it's good to talk through some of the stuff that makes it a little bit more complicated, I think, meets the eye initially.
Mm-hmm. Now, from a research perspective, pretty much everything is done is everybody is either doing all of their work, at a certain distance from failure, or all of the work to failure. And I would say in the field, it's actually, we'll say those would be the two minority conditions, right? Like very few people are taking every set to failure. And the majority of people that think they aren't, right? Which is funny, right? Like it's especially as you become more advanced. I think there's, when somebody is a beginner, right? And even an intermediate, and especially if they're using more traditional exercise or whatnot, like the things that cause you to reach failure are just different, right? Versus when you become more advanced and you have really, really good exercise selection and whatnot, training all the way to failure on a really good exercise with a great resistance profile, and pretty much it doesn't give you the ability to compensate or anything, and you're very safe. You could do so much work. So a lot of the people that think they're doing all of their sets to failure, I mean, who knows? Maybe they are getting to the point where it is legit zero RIR. But I think there's kind of some sway between the physiological conditions that are happening at zero RIR in one person's conditions versus another. But anyway, back on track. In most people probably train some sets further away from failure and some sets close. I know some people will program and they'll try and maintain a linear RIR. So basically you'll decrease load or reps over sets. And that seems to be more common in the strength community, where you're basically just trying to maintain a static RIR. Sure. I think in the hypertrophy realm, most people probably have a descending RIR, meaning that their first set,
3, 2, 1, 0.
Yeah, something like that. Or they're just hey, I just have a top set, right? Or I have work sets or whatever. But and maybe they're not calculating the RIR of those work sets, but what's likely happening is that RIR is getting lower and lower, set by set anyway, or whatever. So even if they're not technically calculating it as a 3, 2, 1 or whatever, it's happening, unconsciously.
Sure.
And we really don't have any representation of that methodology in the research that I'm aware of. Right? We don't.
So my master's thesis has taken this approach that's yet to be published. It's in the meta-analysis, but we still haven't actually got around to publishing that data. So basically, we had for the results that were relevant to the meta-analysis, we had one group that trained at a perceived, so not an objectively defined, but a subjective 4 to 6 RPE, which is 4 to 6 RIR. One group that trained at a 7 to 9 RPE, which is a 1 to 3 RIR. And then the last group did most of their sets 1 to 3 RIR, and the last set all the way to momentary failure. Now, the big caveat with that will be very clearly elucidated in the paper is due to the pandemic, we had some just not ideal issues that would go on for the hypertrophy measurements. So I don't have a ton of confidence in that as a hypertrophy study, unfortunately. Obviously, it's still data. We're still going to report it. It was still included in the meta-analysis, and I still think it's useful. But the confidence I would have in that is just based on the uncertainty intervals on all the estimates are just extremely wide due to probably some of the logistical issues that we ran into. So I think that's it's there. It's just not something I would be super confident in, if that makes sense. But I think I agree with you in the sense that is probably what we need to head in the direction of, like these. And I think there's a few different things in terms of like research that I want to see moving forward in terms of like very ecologically valid questions. Is the other thing I was going to ask you is just where do you put volume on the hierarchy of importance here in terms of, one study I think needs to be done is looking at a not volume equated kind of condition to kind of support the two quote unquote camps that people kind of find themselves in, right? Like the lower to moderate volume, like not like 2 sets per week or whatever that some of the studies that kind of try to look at this question do, but a low to moderate volume taking pretty much every set to failure versus a moderate to high volume and submaximal RIRs. I think that's a study that would be really important to kind of see how that thing shakes out, in addition to some of the things that you're mentioning where we take more ecologically valid approaches to non-homogeneous RIR recommend or prescriptions. So, a condition that, maybe lets their RIRs fall, but they start them a bit higher versus one that lets them fall and they get to failure, or maybe one that reverses the order of the RIR prescription. There's a ton of different ways that you could do it. But like you said, we're not representing necessarily the way that people do it in practice in terms of, okay, every single set is at 4 RIR. Like that's probably not how things are going to go. And then the other thing, just from a practical kind of observation perspective too, I think people often forget is some of the, and this is a question that I still don't know the answer to in terms of one of the indirect questions I had with doing this is like, what are we allowed to count as a hard set? Like, what is that? Like, what's that cutoff? I think people have kind of arbitrarily decided 4 RIR is the kind of the cutoff, but to my knowledge, that's based on essentially zero evidence. Not saying it's not a good or bad practical cutoff, but just from an evidence perspective, I don't think that's really based on anything. And I still don't really know the answer. And that's, so when you have some of these people that are of a lower volume to failure kind of approach, if they're doing warm-ups on the way up to that, presumably there's a few sets in there that probably count to some capacity. So I think that's also something to kind of take into account with the RER prescription, is that I did 1 set to failure. It's like, well, not really, because you did a few warm-ups that probably cross somewhere within the reasonable RER spectrum that led up to that as well, that count for both the volume, but also the non-homogeneous RER kind of thing that you're getting at. So it's tough. There's a lot of things that probably aren't represented adequately in the research that make it even more challenging from a practical perspective. But yeah, that's definitely one that I've noticed as well.
Yeah. I think I've seen like people loosely tying the 4 IR-ish or whatever number to like, hey, in this study, that's where they worked and they got hypertrophy. Like just noting that like, okay, we do have proof of concept that if you're here, you are making, we'll
no, I think it should be 23 RR.
Yeah,
so
right.
So that's
but let me know if I forget to touch on any of those points. But one of the reasons that I brought up the fact that what we tend to do is like lead up to a peak RIR, and that I don't favor the approach of starting with the set to failure.
Sure.
Is potentially by comparing all the sets to failure and then all the sets to the some arbitrary RIR, is that we're kind of losing the signal for the benefits of training to failure by basically having all the sets being to failure, instead of like having that method where we would actually be able to like, okay, maybe working up to failure or having half of the sets to failure in a way that it doesn't, like, you're not having, well, okay, we took the first set to failure and now there's going to be a huge diminishing return in those subsequent sets, right? Essentially the benefit of the first set is being lost by the fatigue of the subsequent sets. And that's one of the reasons that maybe, somebody's anecdote may not align with the research, is because their methodology of applying this is very different than what's in the research. So that's a potential thing that I think could be, like, if I'm just speaking, all of my anecdotes and looking at the mechanisms,
Sure.
I would be like, yeah, potentially if we're trying to do same volume or whatever, if a group was starting and doing that, I might perceive that, well, maybe that first set was very stimulating. Their overall stimulus across sets, especially with the fatigue cost, is being compromised by doing the all or nothing approach to failure and leading with that, versus if we were to take a more ecologically valid, approach of saying, hey, all right, what we're going to do, like we're going to do 4 work sets, right? And we're going to ascend up to a set of, momentary failure. That to me probably would actually result in a better volume of stimulus, because your performance in those earlier sets is going to be better. Because I don't think that, I think that, if we look at the proximity to failure, there probably is a per fiber level thing if it trends along with the force velocity curve. If that mechanism plays out, yes. But the caveat is, if you take that principle, but then you layer it across a lower performance, that principle is being applied to a smaller amount of tissue, right? So it's like, okay, we're still getting higher fiber per tissue by going closer to failure, but where you're hitting a smaller number of fibers under those conditions, because you're doing it under lower loading or, lower volume conditions, right? So we have to take into account that, like, hey, this principle means that we might be getting more stimulus per fiber, but we also still need to be concerned about how many more fibers are active during that time, right? Because if we're trying to grow a whole muscle, it's not just like, hey, if we got this one fiber to get big, cool. Like, no, we need as many fibers as possible to be exposed to those conditions. So this is where then looking at, hey, how do I actually get those conditions in a way where my actual volume of loading is also going to be greater. So I'd be curious, because most of this stuff it's either set or rep matched or whatnot. And I'm curious how much of a drop off of performance we're looking at in those, failure things versus the non-failure. Because I imagine that you're able to maintain the loading a lot better in the sub-maximal groups than you are in the all-out failure groups, right? If not, then I would just question on whether or not they're actually going to failure, or what kind of creatine they're taking.
Yeah, no, it's an interesting question. Like, I guess to me, from again, practitioner hat on, of how I would assess this from a prescription standpoint, to me, the evidence you're looking for there is okay, what actually happens when this person does this? Because to me, there's so many different reasons you could speculate why performance tanks after a set to failure. That's why I kind of said, as far as the fatigue related stuff, I am totally open to the possibility that what you just described is a purely neuromuscular fatigue related event. I just think I remain agnostic on that point relative to the scientific evidence. But from my perspective, from my coaching experience, my training experience, there's a whole lot of reasons their performance could be negatively impacted from that initial set to failure, whether that's just the psychological ability to tolerate that for multiple sets, whether that's neuromuscular fatigue related, whether that's some technique decay related reason. There's a lot of reasons that stimulus could be impacted set to set. And so I think from a practical perspective, it's first, does that seem to be a meaningful problem? And if it does, which does seem to be the case from the research that we do have, I can't recall a study that auto-regulates the load, an acute fatigue study where they fix the repetition range and they fix the RIR, and then they see what happens to the load. I can't recall a study that does that, but pretty much every study that fixes the RIR, fixes the load they're lifting, and allows the repetitions to manifest, that shows obviously a meaningful, a meaningfully greater reduction in repetitions for failure versus the submaximal conditions. So if that's what you're using as kind of the performance proxy, and saying that, you're saying from the theoretical mechanism, is that you're kind of starting that mechanical tension recipe from a lower absolute point, it doesn't matter that in a relative sense you're still getting higher. You still have to consider the absolute difference there, which is important for that overall kind of per session total. So I tend to agree with that. It's tough when you kind of fit in some of the intensity technique stuff, and kind of how does that kind of play into that role there, because obviously a really low rest period set configuration where you're kind of doing a similar thing seems to be pretty effective from the research end of things. And I am of the opinion, at least somewhat tentatively, is because the reason there is that if failure is literally impacting your ability to tolerate that fatigue or actually reach that point, which is conceivable, then it's going to have negative implications. But if you're super well trained, or the exercise is favorable, the loading condition is favorable, the rest periods are long enough, those kind of things, then maybe you can still reach that point. And although the absolute load you're lifting is less, maybe that is outweighed by the relative increase in the stimulus. But I don't know. There's a lot of unformed final opinions I have there, but I the framework in which you're thinking of it is very similar to how I think about it in terms of the optimization problem that we're kind of trying to construct. It's just evaluating what actually happens on the individual level in terms of the fatigue when they reach that. Because another example is somebody that is sniffing ammonia, running around the gym, throwing super loud music on, and then taking a set to failure like it's part of their ethos almost as a lifter. I think the performance decrement you're going to see from a set like that is very different than it's just another Monday where I'm doing dumbbell bench and I'm going to take it to 0 RR and I'm going to put my Taylor Swift in my headphones and kind of take it to that point, right? So I think that's like I'm saying, it's kind of dependent on kind of the way that you came up in the narrative surrounding this in terms of the fatigue that I think it kind of is associated with that. So I think there's a lot of inputs there, and I don't think I said anything that's like a declarative, unfortunately, but I think I definitely agree with the framework in which you're evaluating the costs and the benefits, and then it's just ultimately how does that manifest on the individual level to actually make those calls from a programming perspective. And that's an interesting question. The load reduction thing is that's an interesting kind of another acute study design. If anybody's listening and do some studies, there's two right there.
So the other thing was the relationship between effort and volume, right? Like the Campo.
Yep.
So if there is a benefit of training closer to failure, can we compensate for that with more volume? And I think that the way I look at this is that there's a diminishing return in both directions, and then you basically have this this spot you can play with in between, right? Sure. And I think for most people that are objective with the evidence that we have and have some sort of in the field experience, this tends to be where they land of some people can do fewer sets closer to failure and other people can do, more sets further away from failure. But there's a diminishing level of returns. Like you can only do so much work so close to failure. It just the performance drop-offs just become ridiculous, where it's very hard to intuit that once you reach a certain level of performance that it's still in any way productive or has a cost-benefit ratio at that point in time. And at the same time, on the other end of the spectrum, how low intensity are you going to go, right? You're going to go on a walk for your quads, right? I mean, you could 10,000 reps a day, or take it up to 20,000. And you'd it's very low, it's very far away from failure, but look how many reps you're getting. So there's obviously got to be a point of diminishing returns on the other end as well. So I think basically, as long as you don't take either extreme too far, basically you have room to play with and individualize to the client what's appropriate for the exercises that you're doing, right? And then just the logistics of your program design and whatnot, right? I mean, a lot of programming decisions in the real world are not based off of the physiological limitations, but the practical. Yeah. So, I mean, if you have to get more work done in less time, guess what? You're going to work harder in that time. That's just the way it is. But, for body composition, people sometimes I'm like, look, actually maybe some inefficiency in for a lot of people, this might be the only structured activity that they get.
Sure.
Writing a program that's somewhat inefficient, in terms of hey, this is, if I was trying to get the most out of energy expended, this wouldn't be the way that I'd do it. But that actually might be hey, actually for them, that's kind of maybe what's actually useful for them, right? I mean, not that you should be looking at your resistance training through a calorie lens.
I got you though.
But that person might actually benefit by having a little bit more set volume, or maybe being able to incorporate a few more movement patterns and stuff for a variety of reasons beyond what's max hypertrophy efficiency, bro.
Sure.
Right. So I think it's nice that we have that flexibility. But I know people want just a solid, give me just one way to do it.
Sure.
But but they only want that until it's no longer convenient to do that. And then they realize having the flexibility is great. So I think, there's definitely some population biases to like one way or another and what they want. And it's interesting to see how through people's careers, their training age, and what their profession is, how their outlook on whether or not they want a rigid or flexible answer to these questions kind of changes. Like for some people, like, oh, I want to know exactly what to do. And other people like, oh, I'm so glad that I don't only have to do it that way.
Yeah, that's incredible. That's 100% agree with that. Understanding the principle is only useful when you actually need to use it. When you're just looking for the optimal answer, and that's all you think that's to the story, then you just want the, just give me the T and C right there at the end of it and run with that. So yeah, I agree.
Awesome. Well, I think this is a good place to kind of wrap it up. So there's two things that I like to do here. One is going to be just kind of summarizing, like, hey, what is your, like, hey, we're not like the scientific evidence, we can't make a really hard conclusion either way. I think like pretty much what I just said is probably the closest that, we can get. You had a pretty good summary, I think very similar on the Revive podcast as whatnot. But if you just want to kind of like recap, like, hey, here's how I would put this stuff into practice. And then the last part, everybody's favorite, is going to be the come at me bro thing, where like, so think it's something good.
Cool. All right. So for the kind of the practical summary, I would say, purely from the analysis perspective and what I think we can say from the research, I think we can tentatively conclude, if you accept all the premises of our analysis, which, like I said, went into great, probably annoying detail in the other podcasts about how the analysis has many limitations. But if you get on board with all those, I would say relatively evidence suggests for hypertrophy that training closer to failure is going to give you a greater per set yield theoretically. And then from an actual practical programming perspective, I think this potentially moves the kind of the optimal stress window a little bit closer to failure, to which that optimization problem kind of occurs, where we take in all the factors that we just spent the last couple hours talking about: exercise selection, goal of the client, the loading range, the degree of compensation for the exercise selection, the actual tissue that you're trying to direct the stimulus towards, how many sets are you doing, what's the actual RR prescription look like to actually optimize that curve. There's so many different things that are actually going to end up what you're going to write down on a piece of paper. But the principle is, on paper, there's at least a theoretical benefit to training closer to failure, for which that optimization problem can kind of occur through that framework. So I think that's where I would kind of start from the actual conclusions from the evidence. Cool.
Awesome. I mean, I'm pretty much agree across the board, and I already kind of gave my summary, but the one thing that I would highlight is that don't try never solve a problem with a single variable, right? Like I think that's the biggest problem with some of these conversations, right? Is everybody's trying to look at one variable as just like in isolation, and you're never gonna the research is never gonna be that clean, right? Because we can only isolate so much. Sure. And two, like in the real world, we're never going to be able to apply things and blanket it as just like, okay, it's always this. It's always going to be on a scale relative to the other variables. So I think if you get in the mindset of understanding that all of these things just work in an algorithm towards stimulus, and there's a failure lever you can pull, there's a volume lever you can pull, there's exercise selection, there's range of motion, right? There's all of these levers that you can pull. At the end of the day, you just need to make all of that sum up to as much stimulus as efficiently as you can, with hopefully, minimizing any unneeded fatigue as you can, right? But in certain situations, pulling on one lever may make way more sense than pulling on another. And I think most, like, this is what makes coaching, like, I would say, one, interesting, but also a valuable thing to the client. Because if we could just look at these, like, if client signs up for a gym and we just give them a list of rules, right? Well, then what do they need a coach for, right? It's just like, hey, okay, go, here's the 5 exercises that you do them till like your eyeballs are popping out of your head, right? Take your 2 scoops of, your protein, your creatine, and, drink your water, and then do it again, right? Over and over and over, like whatever, for the magic number of sets and whatnot. And, but that's just not the reality. that we're ever going to be in. So the last thing, which I always like here is the hey, it's your first time on, you got to do it. Come at me, bro. I think, honestly, I think this is what the industry needs more of, or whatever, is like, hey, what is the biggest criticism or challenge to any of the things that you've seen from myself or N1?
Man, first and foremost, this is not my strong suit. I think, that's probably a cop-out to some degree. I think we all have strengths and weaknesses, and also things that lead us to communicate in the way that we do. And I'm speaking this from my perspective as well. I think that's ultimately maybe a benefit in some ways. Like, I think it's easy to have multiple people that communicate information online or try to get principals to critique one another in the way that they communicate. But in reality, I think that to some degree that's actually a benefit, because I think people receive information in different ways. So I think to some degree, like, even the premise of questioning how someone does things is something I don't even know if I get on board with, because although I, as a person with a subjective lens in the way that I interpret and communicate information, may not do things the same way that you do, that doesn't mean that my way is going to get to everyone, right? And if the ultimate goal of communicating stuff online and in the industry is to get people information that we think is going to help them be successful, I would be a hypocrite to initially, to critique anybody's way of communicating. Now, I assume that's not a sufficient answer, and I'm not going to just roll with that cop-out. I guess the only thing I would say, just as a broad kind of sweeping thing for the industry, just for everybody, and maybe this somewhat applies to what I've seen, but again, I would underline my previous statement again, is just I'm just not a conflict person in general, and I think if we kind of evaluate the importance of the things we're discussing in general, it kind of just gets dumb to argue. I don't know. We're talking about lifting weights. We all enjoy this. We have fun, and we're trying to get to the truth as best we can. So, like, arguments in general seems kind of silly to me. So I'm not saying that you're seeking that out by any means. I'm sure that you're not. But I think just as a general principle for most people in which there seems to be potentially emotional disagreements, seeking like communion and trying to initially set up a conversation between those people to talk it out as best you can, I think is just like a good general principle. And so when things spill over onto arguments and subtweets and things like that, it just seems, I don't know, it just doesn't make me feel warm and fuzzy inside, right? I think most things can probably be solved over, a good conversation, two people being honest, and a cold drink. I think, but most things can be solved, but unfortunately it doesn't get to that spot a lot of the time online, but I guess that's where I wish it would go. So that's not really a targeted critique at you or anyone in particular, but I guess that's just kind of my view in general, that, hey, people communicate things in different ways, and people ultimately receive information in different ways. And I think that's a benefit. And I think ultimately, if we all kind of accepted that premise and embraced the fact that we all communicate things slightly differently, we all have slightly different ways of evaluating the evidence. Like the one thing, again, kind of coming back to something I don't think maybe hits as hard for people that are like super interested in the outcomes and stuff, is like, ultimately every single person has like a subjective lens in which they view even quote unquote objective things. And I think that is often colored in the interpretation of the evidence for people. Like, certain people are going to have, like, if somebody coaches predominantly lower tier in the training kind of spectrum individuals, and people that are predominantly focused on getting a really efficient training session in before they go to work, that's going to change substantially the way that they're viewing evidence and the degree of differences between conditions, the types of individuals in the studies that they really value. Like, all those things are going to be completely colored by the lens in which they view that, consciously or subconsciously. And that's the exact same way in the opposite direction. So I think the fact that people have different interpretations of the same evidence is kind of obvious to me. Like, those subjective lens in which we view the problems that's the part that we need to communicate to one another and hopefully kind of find a middle ground. Because I think if we're able to understand those differences in the subjective lens that we're actually permeating the perspectives through, I think most people would kind of just shake hands and, oh, okay, that makes sense. I get it. Like, if you can't really understand why somebody comes to a certain position, I think you probably don't understand their position well enough. Now, whether you agree to the premises that lead to that conclusion, that's a different story. But like, ultimately, you should be able to at least explain why they got to where they got to, and then you can have a hopefully a lighthearted, fun conversation about lifting weights where you may disagree. So I don't know if that's a good answer, bad answer, what you think about that, but that's where I'll go with it.
Well, you can wish in one hand, they say, and you can defecate in the other. It's interesting because I think that's the second time this has been the theme, right? And I'm waiting for dude, you whatever, press around suck or whatever. But so our content must be very technically good. But it's, I would say, one of the things that's always, and because it's a constantly moving target, is navigating social media, how to deal 100%. With that. And the fact 100%. That we have to deal with not only just more people, but a more diverse range of individuals and opinions than we otherwise organically would.
Sure.
And it's interesting how, whatever, I have almost 140,000 followers or something like that, is whatever, and we have multiple platforms, etc. That it really only takes out of all of those people that see our content or whatnot, right? It's okay, there's one or two people that will essentially change the whole, stigma of what's going on and whatnot. And I'm oh, okay, whatever, right? Because I don't know, I could be wrong, but because in terms of online, negative interactions, whether I would think I've had pretty much positive reactions with almost everybody.
Yeah.
But then what's interesting is the people that I've had negative interactions with is most people have also had those negative reactions with. So you see, you're laughing, exactly. Everybody knows who we're talking about without actually talking about them. But I don't know. I go back and forth between whether or not to ignore things, whether or not to respond or whatever. But what I've found is that while seeking out conflict, I don't think is fruitful at all. What I have found fruitful is that using conflict as an excuse to cover a topic or have a conversation. Now, whether the other party in that group then wants to be upset about that or whatnot, I did, in that case, it's well, you brought something up, I responded with how I feel about it. A lot of people be oh, just don't respond to those things or whatever. But honestly, I think that some of the best explanations come after a criticism of an idea.
Sure.
Right? Because a lot of times when you're just trying to, cover a topic, you can't even conceptualize all of the details that you would need and all the questions that, potential people would have. And so one of the things that I like about actually having people critique or I would much rather have a bunch of people that are constantly, saying where they disagree with me on, in a way that I could then say, okay, here's my response to that objection, right? But I think a lot of people can't do that civilly.
Sure.
And so then the decision is, well, if it's one of those people, do you just ignore it, or do you still take that opportunity for the benefit of my following? For the people that follow me, as okay, hey, here's this counter argument, and here's how I would respond to that. And the feedback that I've gotten is largely that's actually helpful, especially because people are not just seeing my content, they're navigating the sea of those ideas. So, well, I think it's great that, everybody can have kind of their own, perspective and their way of communicating. One of the things that I look at, and this is the reason that we take pretty much every course and follow every major influencer, educator, whatever that we can, is we kind of have to understand what the world that our students are living in and what's being communicated to them, so that we can understand how to communicate our ideas in that same world, and also be able to answer questions that come from that. Nothing is worse for me as a teacher when a student asks me a question and I have no idea where this idea came from or the context of it or whatnot, right? But if I can speak on that idea from, oh yeah, that comes from here, I've seen their other stuff or whatnot, I know where they're coming from, then I can more properly communicate with that student. So that's one of the reasons that I'm kind of, I'm okay.
Yeah.
Like, and the other aspect of it I see is that I know like a lot of people have your perspective on it. And I think that that's good. And I think that, this is where maybe I give myself a little bit more leeway than maybe some of the people that want to be like, hey, I'm an arbiter of the scientific community or whatever.
Yep.
Is I'm like, okay, fine. You know what? You don't want to get your lab coat dirty. I will go ahead and I will take some of these criticisms and arguments head on and try and be someone that can kind of operate in that median, right? Like, I don't have a PhD, but I would consider myself someone that is informed enough on both spectrums that I can kind of have those conversations that otherwise would not happen between those parties. And that's exactly kind of what I'm trying to do right now with the little, spat between, science doesn't mean anything for hypertrophy, or everything in hypertrophy is based on science, which, and this is funny. Did you watch the episode that I did with Eric Helms, just out of curiosity?
Yes.
Right. He had a great, so I'll put that one down to the details here for you guys as well. Like, he had a great, like, about 10-minute description, because I asked him, like, what percentage of, like, coaching and practice actually comes from, like, the scientific research versus what is basically the stuff that we're doing from, the working with, like, principles applied to NM1 and more of like we're observing an anecdotal. And, and his response is like, oh, it's like 90% of what we're doing in real time, right? Which is what I would consider like anecdote, because it's specific to that person, right? But then another person basically says like, hey, I mean, not definitely not in the nice, nuanced, contextual way, but basically took the side of like, the stuff that I'm working out myself is way more valuable than the stuff that research has to offer me. And I think if we're being honest, like in the real world, yes, that doesn't mean that the stuff in the research isn't valuable. It definitely gets us to a better starting place. But if we literally were just to be like, okay, if you had to choose between not being able to know anything about your client, but having the research versus the other way around, you probably be like, no, actually what I would like is I would like to be completely ignorant to the research and be able to actually track and observe what's going on with my client. Like you would probably pick that. And I mean, both of these things should exist in harmony, but I just think it's funny that definitely the messages were not delivered the same, but in a way they're both leaning towards like, hey, this other thing is very important. And the context of the latter being somebody that is, we'll say, as far on the advanced spectrum as you could get, right? Which means contextually so looking through that lens, it's very easy to see how you could get to the point where like, look, I mean, I've been training for 20 years. Like there's probably nothing that's going to come out in the research that's going to be more informative than my 20 years of training.
Sure.
Like probably, right? Anyway, and I think that's where, people that have a lot of experience in the field, but also are kind of in the, in the scientific community or whatnot, can kind of be like, can kind of have those conversations. And occasionally that means that we're going to have to piss off one side or the other, at least for a minute, right? To be able to get that conversation going. And that's kind of something that I found is that I have had to, we'll say, turn heel acutely, at least in the eyes of somebody, to get the pull of like, now we can actually have a conversation on this.
Sure.
Because otherwise it's just dismissive, right? But there definitely is a line. Right? Like, so that doesn't get into ad hominem. That just means like, hey, I'm going to push a pretty strong counter argument to this, but I'm going to do it respectfully.
Yeah.
But sometimes people can't reciprocate that. And then it's like, hey, because you challenged me, I'm not going to reciprocate in that way. I'm going to escalate it. And that's the unfortunate situation that I think, you know, I've gotten in. These guys currently like debating the, you know, what matters more, science or anecdote, like that they're kind of getting in. It's just like, once it escalates to a certain point, that I think that's just well, now we're in a bad place, right? And it's hard to come back from them, like, especially if you're the other party. Like if you're having a debate with somebody and then they take it to the next level, it's emotionally, it's hard not to just respond with that. But also then it just kind of like, it makes you just want to cut off the communication, you know, or no longer discuss it, because you're basically like, all right, well, how am I gonna continue to articulate valid, objective, you know, ideas or counterpoints when all it's happening is I'm getting, you know, just like ad hominem, you know, in the other direction, right? And so it's basically, I don't know.
Yeah,
but anyway,
I think
that's my defense.
Yeah. Just add one thing onto it, and not to belabor too much. I guess just to be clear on my position, like, first and foremost, I think defending ideas is crucial. Like, that's how we get closer to the truth, right? So I think that position, discussing these things, you know, going back and forth on interpretations of evidence and clarifying those subjective contextual points where the interpretation may differ, that's absolutely vital. So I that's, in no way do I want to dismiss that at all. I think the tough thing comes, so the way that I view this just from an online perspective, and once again, these are just general points, I'm not talking at you necessarily. The tough thing comes when how like comparing how you would handle a disagreement with somebody you know extremely well in person versus handling how you would handle a disagreement online. And I think the part of handling disagreements that's challenging is, like, when you know somebody extremely well, the part of the equation you are pretty intimately familiar with is how somebody else receives information. And then you can tailor the way that you deliver a disagreement towards that. And so online, particularly when we don't know somebody particularly well, even if you've had multiple online interactions with somebody, it's a very different thing of knowing how somebody handles disagreement in person. You can read their nonverbal body language, all those kind of things. That paints a better picture on how somebody receives information. So I think when you have disagreement, or when you're challenging somebody else's position, that's the point of the equation that's really challenging to get right. But I also think that's the most important part to focus on, because while me and you may handle critiques and criticism in a very specific way, and that's how we're evaluating the other half of the equation, the reality is people handle disagreement very differently. And I think that's the part of the equation that can lead to a very different outcome, even if the input is the exact same. So I think just spending time on thinking about how other people receive information, even though we feel like we're delivering the same exact point, the way in which that's communicated can lead to a very different outcome, which is challenging for all communication. And now this is completely unrelated to resistance training, but it's an interesting conversation nonetheless. So I think yeah, that's just like a general challenge of communication, science communication, social media in general is, okay, I know how I receive information, and you're kind of making a prerequisite assumption that I'm assuming most of my audience is people like me, so let's communicate how I feel like I would like to receive information. And that's probably a challenging bet a lot of the time. And probably the to use a pun here, the way that people receive information probably is also N of 1 as well.
Yeah. Well, I mean, to relate it to what we're doing, there's a diminishing returns on both ends of this.
Sure.
And you got to know when and where to pull that lever.
There you go.
Right. So there you go. See, it's back on track. Cool. Well, all right. Well, so since that wasn't resistance training, I'll put you into a black and white stance, right?
Sure.
Training at long muscle lengths, you know, bees knees for hypertrophy, yes or no?
Sure.
Sure.
Camp.
Okay. Yeah. All right. You know, I think that's going to be an interesting conversation. You know, that continues to go on, right?
100%.
So, all right, cool. So, where can people find you, see more of your work, all that good stuff?
Sure. Yeah, you can just head over to my Instagram at zac.data-driven-strength on Instagram. Hit the link tree in there. That's pretty much access to everything we do. Obviously, Kassem, thanks again for having me on. This was an awesome conversation. Got into a lot of the nuances that I think a lot of people don't think about the analysis at face value, which I think are incredibly interesting and ultimately can paint a pretty different practical implementation picture depending on kind of where you're on a lot of these spectrums that we kind of talked about. So I think this is a cool conversation that definitely adds a lot to the other ones that are out there. So I appreciate it, and thanks for having me on.
Yeah, you're welcome. It was great to have you. And I think, you know, the more that we can do these kind of like, you know, conversations between, science and people that have a tremendous amount of field experience or whatnot. I think these are fun conversations, and I think that's where the most practical outcomes, come from this stuff, right? So cool. Thanks everybody for tuning in, and check out all the details in the bottom for the Revive podcast. I'll put in I'll put in the link to the quote from Eric Helms, and all of Zac's details down there below. So thank you everybody, and we will see you on the next episode. If you enjoyed this episode, make sure you give us a like, subscribe, and leave us a review, and we will see you on the next episode of the N1 Experience.